This next video in my Casting Shadows series is about shadows of overhangs. Check out Ellen's Guide to Casting Shadows on Amazon. Let's find the shadow of this horizontal rectangle on a wall. And the first thing we do is set up the seats, and the seats should converge with the rectangle. Then find a shadow direction that's different from the seats. When it hits the wall, it goes vertically up until it intersects the light in two places, and then it goes to the nearest corner. I want to introduce you to the upside-down light triangle that we can use when the overhang is flat. So start with this corner and draw a line toward the shadow vanishing point until we hit the brick wall. So we go underneath the overhang. That's the beginning of this vertical pole. Then draw a light from this same corner toward the sun up here. And where it intersects this pole is a point on the shadow. Now, if we take this upside down light triangle and actually turn it upside down, we get what we usually see on the ground, namely a vertical pole with light going through its top and the shadow direction from its base. Let's try to understand this shadow. So first, draw light rays that we know go to these different points on the shadow on the ground. Then draw a parallel light ray from the shadow line. It meets the line here in the shadow direction. When we set up our seats then, we need to make sure that the shadow direction parallels this first one, and then we can find these different intersections on the ground. Now, to find the shadow under the overhang, you can start with the seat over here that's under this part of the overhang and draw a light ray through its bottom. And we get an intersection here as if this whole surface is extended. You could see that the shadow direction is here, and then it goes up this imaginary wall to go to this intersection. And that's the shadow line. Another way of doing it is the upside down light triangle that I just discussed. So this goes in the shadow direction. It gives us the top of the pole, and the light ray here going down to the pseudo-sun gives us the bottom of the pole, which is the same as the shadow line. To find the shadow on the wall from the overhang, we first have to find its ends. So one end here is in back of the floating box where it meets the upright boxes. The second one is found by extending this front surface so that it's level with the upper box. Then set up seats, and for seat number 4, the shadow direction happens to be horizontal. It goes vertically up, and it intersects light from 11 and 13. You can see that they both use seat number 4, and they intersect this shadow line in two places. The other seat from number 3 hits the wall at number 6 and goes vertically up, where it intersects the light from number 12. To find the shadow on the ground, start with the light ray from the shadow line going down, where it intersects the shadow direction from the corner of the block is intersection 3. Then set up a seat so that the shadow direction is parallel to this first one, and where it meets the light is intersection 4. Now, what about this shadow line? We'll have to use this seat number 6, and light ray from the top of it goes to number 1. The line here goes to the base of the box and then up, and then intersects the light at number 1. Now, what about this last shadow direction? Use number 8. The light goes down to this point. The shadow goes from 8 to 9, and then it goes vertically up as if this box were extended. We can always extend a surface if it doesn't affect the shadow. And you could see that this shadow would be the same whether it's a thin box or a thick box. And number 10 then gives us this shadow line. This image is front lit with the pseudo sun down here and the shadow vanishing point up here. I set up a few upside down light triangles giving us this shadow line, and I want you to see that the shadow direction on the roof is the same as the shadow direction on the ground. For this structure, I drew an upside down light triangle, and where the light hits the edge is the shadow line. I did another upside down light triangle here to establish this shadow line, and one of these is enlarged here. Now, since this is eye level, most of this building is above eye level. We're looking up at it. As a result, this shadow line is higher because it's closer to us than this deeper part of the shadow down here. Now, for the shadow on the ground, you start with the corner. You go to the intersection here that begins at the end of the shadow line. Then you go to this intersection, which is where the top of the overhang receives light, and then you go to this intersection from the seat. So the shadow goes from number 2 to the pink intersection, to the green intersection, to the purple intersection, and then parallel to the back of the box. For this structure, the light rays are parallel and the shadow direction is horizontal. For the first light triangle, start at the tip of the overhang and draw the shadow direction until it hits the wall. Then it goes vertically up until it intersects the light, and that marks a point on the shadow line. We go to the end of the shadow line for the second light triangle that defines this intersection here. And the third light triangle uses the two top corners that go down, and they both use the same shadow direction. So as a result, we get a beveled edge here. And compare this shadow to one without an overhang, and you can see it's much more interesting. Now, this is a little complex, but it's all the same concepts. So we set up the seats for the floating box. The shadow direction hits the wall, then goes vertically up until it intersects the light. And this one goes to number 7, which lies between this box and this box. The one from 4 goes up to 6, and we don't know where 8 is yet. So let's go the other way and establish seats for this vertical box. And the shadow then goes in the shadow direction until it intersects the light. So I had to extend the surface to find this point. Alternatively, you could just go in the shadow direction, then vertically down, and then in the shadow direction. Now the last part is to find these two intersections, 11 and 12, so that gives us this line here, and where it hits the edge is number 8. So we established these two components, the shadow direction and the vertical direction. But these are not shadows because even though they follow these seats are imaginary. Then we have a diagonal and a horizontal converging line from this horizontal pole, and that's it. My next video is about shadows of houses, and if you subscribe, that'll make my day.